Hey, thank you very much for coming. I'm very honored to be able to talk here today. This is my third time at Pycon Ireland, but my first time as a speaker, and I'm very excited. The talk quality, I feel, is always very, very high, so I hope I can keep the standards up. I'm going to talk about, ironically, the Go programming language, but this is not a talk that's here to convince you that Go is much better than Python, because I don't believe that either. I'm a big Python fan. I've written Python, well, not for that long. I've only been in the industry for 2.5 years or so. But I do believe that in certain cases it's good to keep an open eye, right? I think the subject of code-based diversity, which is the second part of the talk essentially, is something really, something really important. And yeah, basically that's what we're going to talk about. So this is not Go is better than Python. This is what can Go possibly do better than Python, and when will it be potentially a better choice, right? Yeah, that was what my presentation initially looked like, because I used emoticons, but that didn't work out at all. So I'm going to use pictures in the rest of the presentation. Good, about me, that's me. I'm, as was already mentioned, an automation engineer at Demonware. We have a stand out here today as well. Demonware is a subsidiary of Activision Blizzard. We make online game services for Call of Duty and the likes. Whenever I don't write software, I play the drums, I cook, or I drink beer. I like consistency, so my my social media handles are usually all the same. The one at the very bottom is Untapped, which is for rating beers. Yeah. Okay, before we go into technical stuff, I want to just give you a little historical comparison between Python and Go. As we all know, Python is not necessarily very young. Python just was started to be implemented in 1989, the same year as Taylor Swift was born. In 1991, we had the first release, and already with inheritance, exceptions, and core data types. In 1994, so that's 13 years ago now, right, we had version 1, and functional tools were implemented. And I only found out a couple of days ago that Guido van Rossum, so the core founder of Python, essentially doesn't really approve of functional tools, which I found to be very interesting. Version 2 in 2000, 17 years ago, we got list comprehensions, which we all love very much, and full garbage collection. 2001, 2.2. That's one of the greatest things about Python, in my opinion. It's fully object-oriented. Unlike Java, which probably a lot of you know, in Java you have this concept of an int, which is a primitive type, and an integer, which is a class. And that makes Java basically not a fully object-oriented programming language anymore. But ever since Python 2.2 in Python, that is the case, right? A type is an object, or a type is a class in that sense. 2006, Taylor Swift released her first album. I don't know the name of it, but. And 2008 marked the day 2008, version 3 of Python came out. And if we go to Go now, it was only 2009 when Go first appeared, so that's not very long ago, right? We had version 1 in 2012, and in 2012, Go already contained most of the things that we know about today, right? So one of the key core points of Go is that it doesn't really change much over time, right? 2015, just 2 years ago, we had version 1.5. It was originally implemented in C, but as of then, Go and assembler. And August this year, we have version 1.9. Good. So a huge part of the presentation is going to have this slide style. On the left side, we're going to have some Python code. On the right side, we're going to have Go code and a bit of shell on the bottom. Good. And let's get started with it. Python is mainly an object-oriented language, not just, but it is, amongst other paradigms, mainly known for its object-orientedness. Go is what I like to call a concurrency-oriented language. And you might think initially that concurrency and object-oriented, like you're comparing apples with oranges, but not really. Concurrency is a way to structure your software, right? But Go also implements a couple of things that object-oriented languages know, like encapsulation, which is actually really ironic because Python doesn't really have it. Good. I'm just going to start off with this hello world example. We're going to get into more depth soon. But you can initially see that Go demands from you more from the beginning on, right? You need a package. You need to import something, just print something to the command line. And you need this main function, right? Reminds a lot of C, reminds maybe a bit of Java as well. And with Python, we literally just have this one-liner. Compilation. Python compiles to Python bytecode. And you need an interpreter to run this bytecode, right? So you could technically compile just your Python code into Python bytecode with that PyCompile module there, but I don't think anyone really does that, or I don't know. If we look at the Go side, we compile it directly into machine code, and we get very large binaries. So my question for the audience, why are Go binaries so big? Anyone an idea? Sorry, what's that?
Because it includes the whole runtime.
Yeah, that's correct.
And it's much more smaller than the Python runtime.
Yeah. That's totally correct, yeah. So, yeah, Go binaries are fully self-contained, right? They already have a garbage collector in them and the whole runtime, essentially. And most importantly, they include dependency code, right? If you use a library, a Go library in your program, it's going to be inside this single binary, right? And you can distribute it really easily. You just need to obviously compile it for each target architecture. Manipulating arrays. So I also found out that some people think that one of the paradigms of Python is that it is functional, which I find really weird because you can do that. You can put an array into a Python function, manipulate it, and without actually returning it, the values would change, right? So we get in 1, 2, 3 here, increase the numbers, we don't return anything, and then print it again, and then we have 2, 3, 4. So that's a side effect, right? That's not functional at all. You can do the same thing in Go. You can pass in this array that we have here. We define an array with those 2 empty brackets, then say which type it is, and then put the numbers in. And now we have an initialized array with the numbers 1, 2, and 3. And we can put it into this function over there, increase the numbers by going over this, by basically iterating over the numbers in it, increasing them. And then without returning anything, we print it again in the main function. We have this modified array, right? Side effect again. So I was lying to you there. What you just saw there was, wait a second. Yes, what you just saw there was not an array. We see here on the left side what you just saw before on the right side, right? So what's right here is left here. We can see we pass in this array, change things, and then it comes out differently again. If we do it on the right side, we do the exact same thing, but nothing happens. It still says 1, 2, 3, even though we increased numbers. What's the difference?
You're using slices on the
Yeah, exactly.
arrays, which are slices above.
Yeah, so Go has a concept of slices and arrays, and the difference in when you create them is basically just that an array needs to have this fixed size, right? So it instantly becomes an array then, once it has this size predefined, and it's passed by value as of then. A slice is passed by reference, so you can manipulate it. You cannot manipulate an array, which also means that an array is fixed size and the slice is extensible. General rule of thumb is that you should use slices whenever possible. Identifying semantic inconsistencies. So the speaker before me just talked a lot about bugs. If we look at Python, and we have this code here, we just want to get an item by its ID from a database. We just assume that getItem by ID is a function somewhere else, and that IID is the item ID, right? And we retrieve that item with that ID from the database, and then want to get its name. So there's a semantic inconsistency, so a bug. The same bug, essentially, on the left side and on the right side. It's a bit hard to spot. It's that thing here in the exception. I'm trying to raise an exception with ID instead of IID, which doesn't exist, right? And on the Go code side, the same thing. So what's the big difference here, though? if IID exists in the database, then Python will just happily run that code and nothing happens. On the Go side, however, it will check during compile time all the code we have and will see that ID is not in the scope, right? The variable ID is not available there. So we get an error. What does this mean for us as developers? It means that if I write Python, I should work towards 100% code coverage. Now, 100%, obviously, that's not something we'll probably ever reach, but I have to work towards it because I need to check all the paths and see if maybe I have typo in there, right? There are checkers for that, obviously, but naturally, it's not there. Go, on the other hand, checks that for us on compile time, and instead of rigorously testing each single path in there, we can focus our tests on our business logic and its semantic correctness. So you might say, well, actually, if I write code, I might want to strive for 100% code coverage. That's a good thing. I always want to do that. Well, it's controversial. Program testing can be used to show the presence of bugs, but never to show their absence. That's what Edgar W. Dijkstra said a while back already. To pull out an analogy here, imagine there's a fly in this room, and we want to write tests to find this fly. Well, we might not find a fly in our test, but that doesn't mean that it's not there, right? The probability of there being a fly in this room, even though we have no evidence for a fly in the room, is greater than 0. And that's the same with bugs in our code, right? Just because we haven't found any bugs doesn't mean that there aren't any. Good, encapsulation. I talked about that before already a tiny bit. In Python, we have this convention that whenever we start a variable with an underline, we basically want to treat it as private. But the joke is we can still access it from the outside. There's no true encapsulation here. Now, I found out that you could actually do double underlines before the variable, and then you can't access it anymore. You'd need to change the name. It's called name mangling, but that's not the official convention, right? In Go, that's a bit different. In Go, we have this concept that whenever something is written in uppercase, so that can either be a type or a function, it's available from outside the package, right? So in this case, we have a person here, and the person structure has an age and a PPS number, but we can't access the PPS number from the outside. We can, however, access the age, right, and change it as well. That's true encapsulation, true encapsulation. Interfaces, that's one of the greatest things about Go ever. So Python obviously doesn't need interfaces because it's duck-typed, but Go has inferential typing, and it's not dynamically typed in that sense. So interfaces come in handy. And the coolest thing about that in Go, the coolest thing about interfaces in Go is that they are implemented implicitly. So you define an interface which has a couple of functions, methods actually, in that sense. Here in this case, it would be add item. And as soon as one of my types implements all these functions that are defined in the interface, it implicitly implements the whole interface. And I can treat my SQL storage here as a storage, right? Now, what makes this even more interesting is when it comes to error handling. We see in Python we have exceptions, and every class that inherits from the exception class is basically something, an exception itself. It can be raised, right? On the Go side, everything that implements the error method is an error interface and can be raised as an error in that sense. We don't have exceptions in Go, but we do have errors. You will see very often that, very, very often in Go code, you will see if error is unequal nil, then do something, right? It's very similar in C, the same thing, right? We execute a piece of code, we execute a function, and then check the return value. It's the same in Go. So if we look at error handling here in a practical example, we are raising this not of age exception here, and in our main function we try to catch it, and we can check for the type of the exception by either except not of age exception or except other exception. Right, and so we can treat those exceptions differently, right? And we do the same thing in Go, just slightly different. We can check here, if you see in the second box down there, that so E or R, we can check, is it the out of age error? And then we can treat it differently, right? Good. So the strongest point about Go, as probably most know, is concurrency. Here's a little example, a little Python example. There are loads of ways to do concurrency in Python, and I'm not very, very familiar with them. But this is one that I found on the internet. It's not too complicated. It's doable, right? We have this compute class, which inherits the threading.thread class, and then we can run our code concurrently by running this class and then say start, and then the run algorithm will be executed concurrently, right? In Go, it looks like that. We have this Go keyword, and as soon as we run something with the Go keyword in front, it will be started in a separate Go routine. We'll come to that in a minute. Originally, you already have, so this main function basically itself is already the first Go routine we have when we run our application. If I were to put a Go in front of the second compute function call as well, then both of those Go routines would be started in the background, and the main Go routine, which is the main function, would terminate instantaneously, and we would be left with nothing. Cross-routine communication, yeah, I'm just going to go quickly over that. If you're interested, channels is a great concept that allows us to communicate between threads, and we don't need to worry about synchronization ourselves. We don't need to block anything. We don't need to use semaphores or whatever. The channels do that for us. That being said, channels are not always the right solution. Good. Go routines are similar to threads, but much, much smaller, and they're multiplexed onto operating system threads, right? And operating system threads can be run on multiple processors if you're lucky enough to have a computer with more than one core. Which means that automatically our Go routines, our threads that we had before, remember this Go keyword, will be run in one of the light blue boxes now on top of one operating system thread, which may or may not be on a different processor core. So if it's appropriate, the concurrency turns into parallelism, right? But you don't really have control over that. That's all done inside Go itself already, right? So you have this global variable called Go max prox, and as soon as this is greater than 1, then Go will try to distribute your threads across, will try to distribute your Go routines across threads on separate processor cores if it's appropriate. So you might have heard of Rob Pike, who is one of the main implementers of Go and a great speaker. And he's saying that parallelism is not the goal of concurrency. Concurrency's goal is structure, right? So we don't write concurrent code because it is important for us that we run our software parallelly, because that's not the same thing, right? Concurrency means two things. One thing doesn't have to finish before the other one starts. That's concurrency, right? You can do a bit of this and a bit of this, but it doesn't need to be at the same time, right? It just, you chunk up your tasks into small pieces. That's concurrency, and it enables us to do parallelism further on. What I found is that Go on the syntactic flavor scale is significantly more salty than Python. Python has, this concept of list comprehensions. We don't have that in Go. We need to write our for loops explicitly. Now that's a conscious decision, right? And you might like it, you might not like it. It's up to you, but it is. That's the fact, right? An example, well, the other thing is Python has syntactic salt, obviously, as well. Everyone knows about the enforced indentation, right? That's syntactic salt. Go Go, on the other hand, has different kinds of salt. As we see here, we have this package main, then we import the standard library module FMT, but we never use it. And at compile time, Go will complain that we never use it and will just not run the code, right? And the same goes for unused variables. We define this variable a equals 1 here, but we never use it, and Go doesn't allow us to do that. Formatting, just really quickly, Python, we have PEP8, which is, yeah, I don't know, 79 characters per line. Then we have GoFMT. GoFMT is optional, but very, very much recommended. GoFMT will format your code for you. You write your code, and then you run GoFMT, and it will structure the code according to the GoFMT standards. So one of the GoFMT standards is tabs instead of spaces. If you don't like that, you're out of luck, because that's what's gonna happen if you run GoFMT. And if you're developing on a project on your own, it might not be such a big deal. But if you collaborate amongst other developers on Go code, right, run GoFMT, always. Dependency management, now that's a bit of a mess in Go, but it's probably everywhere. In Python, we have pip, and in Go, by default, dependencies are defined by referencing the master branch of a Git repository, right? And that's where it's pulled from. So if we reference a Git repository, the code we depend on will be pulled from the tip of the master branch of this repository. That calls for trouble. That's why a lot of very, very intelligent people work on better solutions on that. But up until now, this is still default. So what's my personal experience with Python and Go? I think Python is great to get started on. You know, Python starts off really very shallow, but then as soon as you start to write applications that demand a bit more of you, it starts to become really painful, and sometimes you feel that you wrote something really simple, and then the application grows, and you can't hold the pieces together anymore, because your code just became this mess, and you need to restructure it completely. With Go, I feel like it's a bit different. You start off, it demands from the beginning on already a bit more of you. You need to take care of what you do, right? Again, the compiler helps a lot here. But what I feel is that when the application grows along, you don't need that much more effort anymore to grow with it, right? So I feel that Python is great for scripting. I don't think Go is appropriate for scripting at all, although a lot of people seem to do it, but yeah, okay. Good. So why am I telling you this at all? Like, you like Python, why even bother learning a new language? Because of science. So that's a bit of a mouthful, but it says, this is an excerpt from my academic paper from 2000. It says, both theory and observation indicate that genetic heterogeneity, amongst crops that is, provide greater disease suppression. What does that mean? Imagine we have a monoculture of only red apples in our garden and a polyculture in our neighbor's garden. And now there's this bug coming to us that eats all the red apples, right? So we have this bug coming in, eating our first red apple, and then he sees the next one, and goes to the next apple and eats it, and goes to the next one and eats it until all our apples are dead. In our neighbor's garden, it goes to the red one, eats the red one, and then sees a different one. And might think, well, maybe there's not so much for me here to eat, and leaves. I'm not sure if this analogy works with code, but it might, right? Maybe a bad coding practice, the bug in this sense, spreads easier if we have a monoculture amongst our code base, right? If all of our code is in one single language, it might be easier that we fall into this pit of a mindset, and we have a fundamental error in this mindset, but we don't even notice it, and it just spreads across all of our code base. What if this isn't true? It doesn't really matter, because there are loads of other reasons why you should consider using not just one, but multiple languages in your organization. Imagine you have a company that only writes Python code, And then you come across this really cool tool that you saw and would really help you, you know. But the problem is it's written in Go, but you need to fork it because you need to adapt it. But it feels out of place because everything's in Python and you don't just want to fork this Go application. Well, if you have a more diverse code base, then it's not such a big deal anymore, right? People already know different languages, and even if it's one new language, it doesn't really matter anymore. How about the employee market? Imagine, again, the company, just Python, and you want to hire someone. Now, you might not care so much if someone has experience in a specific language, as long as they're a good engineer, right? But people might care. If someone's really fond of Haskell, that's the first logo up there, and they see there's absolutely zero chance that this company is ever going to use Haskell, then it might not want to work for us, right? If we have a more diverse code base again, we still don't use Haskell in this case, but the guy might think, well, they're using loads of different languages, right? Maybe I can get them to use a bit of Haskell. Well, there's a better chance for us to get more engineers, just right. It offers us perspective. Different languages have different strengths. They give us different perspective on things. Go works just differently than Python. And we might see implementations in Go that make us think, well, that's actually a really great idea. Maybe I can do something similar in my Python code. New languages mean new challenges, which is great for employees and which is great for the company because it drives innovation. And eventually it all comes down to using the right tools, right? Python is, again, a fantastic language, but it might not be appropriate everywhere. What would be a great talk without mentioning Docker? Having a lot of different languages means that my environments might have to look differently, right? Because, you know, the language might require different things. Like I need to have Python installed on my on my target machine in order to run Python code. But for my Go code, I don't because it's a binary. So that diverges, right? Why do I have to maintain two separate environments now? Well, we can encapsulate those things with containers. We prepare our environment once inside a container, put our application there, and ship it. And we don't need to care about the target host so much anymore. A bit, of course, but not so much anymore. Containers provide the abstraction for that. That's great. Good. What's the time? 50. Yeah, good. Here are some references of people that really inspired me while I was doing some Go programming. There's Francesc Campoy. He has this series on YouTube called Just for Fun, which is fantastic. Rob Pike, as I just mentioned before, especially his talk on concurrency and parallelism is fantastic. And maybe you use already some software from the company HashiCorp. They write pretty much everything in Go. Yeah, that's something to look into. Thank you very much. Questions? Any? Nope. Okay.
So you mentioned some of the, let's say, structural differences between Python and Go.
Sorry, what?
Structural differences.
Structural.
Right? So you mentioned about these things.
Yeah.
Do you have any relation to how would you, for which purposes would you think one might be better than the other?
Yeah, so if we look again at things like concurrency, right? Concurrency is already something that's so fundamental in Go. And it splits up our tasks in little chunks. And I think concurrency is not only here to make our software parallel. It's also just a really good design decision, right? Well, what's a use case? I think just if you have software that might have algorithms in there that you're unaware of how much time that will take eventually, you maybe want to consider writing them concurrently, and that's much easier in Go. Does that make sense? Cool. Okay. Good. Yeah.
So in my previous company, actually, we also kind of used Python and then started to adopt Go for some of the reasons that you guys mentioned. But we found it really hard actually to bring in a new language. And I wonder, like, from your experience, like, what did you find hardest in actually getting all the engineers to learn a new language, and how did you tackle it?
You have to make it. You have to make the engineer see why it would benefit him as well, you know, like, or her. It's just. I think adapting a new language is like adapting a new tool, you know. It doesn't really. People are always a bit reluctant when it comes to change, but I think bringing new challenges in, there's something in it for everyone, right? Bringing a new language in, I can see that someone who has written Python for the last 20 years doesn't necessarily want to learn a new one now, but you know, that's part of being an engineer, I suppose, right? You have to be open-minded a bit, I suppose, right? Yeah. Okay. Thank you very much.